Okay, welcome back. So now let us talk about the limit comparison test, okay, related with the integrals, convergence or divergence. So here is the limit comparison test. So given fx and g of x, both positive functions, okay, and also they're both continuous, on the interval from a to positive infinity. Okay, so the limit comparison test says like this: if limit as x approaches infinity, fx over g of x equals capital L. Okay, of course this L is some constant between 0 and infinity. Okay, and then integral a to infinity fx dx and integral a to infinity gx dx either both converge or both diverge. Okay, or both diverge. Okay, so the basic idea here is you can see that from the long-term run, okay, and the fx and the gx, they behave like proportionally, okay, from the long-term run. That means as x goes to infinity. And then you can also think about it, you know, after we apply the integration on both functions from the long-term run, their behavior also behaves proportionally. You can think about it into that way, okay? Not very accurate, but you can think that in that way to help you to understand. So if one of them converges, then the other one, since it's loosely speaking, it's like proportional, it must also converge, okay? And same thing, if one is diverged, the other one is also diverged, okay? So now let us look at one example here. Example. So if we have 1 to infinity, 1 over x squared plus 1 dx here. Okay, and then we would like to know whether this integral is converge or diverge. Okay, that's the question here. You know, to apply the limit comparison test, this is the function we have, and notice that we also need to find another function. Okay, the rule or to find the other function is you know, based on what you have. Trying to think about it, are there some similar functions with less complex, okay, compared to the given function. So for here, you see, if I denote fx as 1 over x squared plus 1, and very naturally, you can think of, well, maybe gx could be 1 over x squared. Why? Because, you know, those two look similar, but this 1 over x squared, definitely it's easier, right? Looks like it's a more clean and neat function compared to this one, right? So, yeah, so that's the way to find the paired function here, and we can check limit as x goes to infinity, fx over g of x, which is limit x goes to infinity, x squared over x squared plus 1. Now to evaluate this limit here, we can apply the L'Hopital rule because both top and bottom, they are infinity over infinity type, the indeterminate form. So the L'Hopital rule says this: its limit as x goes to infinite, the derivative of the top, which is 2x, over the derivative of the bottom, which is 2x. Turns out this limit equals 1. Okay. So we got that, and then it satisfies the limit comparison test. So we can check integral 1 to infinity 1 over x squared dx, and turns out this integral, it converges. Okay. And why it converges, or how to see it converges, you can take a look at the previous videos I posted on this channel. So this is converge. We can get to that conclusion: 1 to infinity 1 over x squared plus 1 dx also converges. Okay, and then we finish this. Okay. So hope you enjoy this video, and thank you for the watching.